So this is example 20E from page 75. And this is an example question where we're identifying which substance is being oxidized and which one is being reduced. So when you're dealing with these redox reactions, remember that means that we've got a combination of a reduction and an oxidation happening. You want to start it off by making this before and after chart. So what do the substances look like before the reaction and what do they look like after? And then we compare them. When we have ionic compounds, we have to show those as ions. When things are by themselves as an element, we show them without a charge. So calcium before the reaction is just Ca solid. Here I've got a compound that's made up of H plus and OH minus. So I'm going to list them as the ions. After, so I produce this new compound, which is an ionic compound. So instead of showing it like this, I'm going to show it as the ions. So calcium has a charge of 2 plus, hydroxide is OH minus, and lastly we have hydrogen gas, which is not part of a compound, so I just list it as H2 gas. Now we want to look at which one of these is gaining electrons. This is a reduction, so GER, gain electrons reduction. Which one is losing electrons, lose electron oxidation, so Leo, GER. And then which one's just a spectator, so nothing really is happening to it. It's not being oxidized, it's not being reduced, it's just kind of hanging out. And if we do look at that, which one stays the same? On both sides, I've got hydroxide ion. So it has not gained or lost any electrons. It's staying the same on both sides. So this is my spectator. Gain electrons reduction. So whatever gains electrons means that the charge is going to be reduced. So if we compare, my charge on calcium goes from 0 to 2 plus, so the charge increased. Here we go from positive 1 to 0, so my charge is reduced. That means hydrogen must have gained electrons. And calcium, the charge increases to 2 plus, so it has to have lost electrons. So calcium is being oxidized. When we actually define these, we call the thing that gets reduced an oxidizing agent. Okay, and then the thing that is oxidized, it's the reverse. We call this a reducing agent. So just think of it as the opposite. If it gets reduced, it's an oxidizing agent. If it gets oxidized, we call it a reducing agent.